Good evening, all. Once again, um, we'll start the class now. So, first, good evening, and I welcome you all to software testing class. My name is Yemi Ayola. Um, I'm a software tester. Currently, I work with an insurance organization, and I work as a senior test analyst there. I've been testing for over a decade now, and I've worked with different organizations, both financial organization, investment and asset, insurance, and also data warehouse organization. So all these have been my journey all the while. I'm still happy I'm still testing up to date. Today I'll be taking you on the software testing and mainly manual testing. And I'll start with introduction to just the class to just welcome you all from everywhere from Nigeria, London, part of the world that you're watching listening to this lecture tonight. So hopefully, whatever question you've got, please just put it in the chat, and I've got my colleagues on the ground who start answering your questions. So once the class starts, any question you have, just pop into the chat. I'll take some break also and read some of the questions and see the ones that have not been answered. Then we can actually now I can explain more. And any question at any point in time, please do not hesitate to just put it in the chat. So this is, as I said earlier, this is introduction to manual testing, and we'll be going through some of the topics and for this class today. So yeah, first I'm going to start with background of software testing. I'll take predominantly just say before you actually want to do anything, you just want to have an understanding of the career path of whatever you want to do. You like to gain an understanding, know what I'm going into, what are the backgrounds, what are the things that entails for me to be able to do anything in life. So hence I'm just going to give you a bit of background of testing before we start going in depth into the course. So I'll take just real life scenarios for us to just be able to look at it. That what is software testing? What is this manual testing? Everyone is talking about testing. Everywhere is testing. So you just want to know that what really is this testing? Is this testing the same thing I understand? Yes, testing is in various forms, different parts, any aspect of life testing is always involved. I'll take, for example, if you've got running water in your house, you've got your tap, your cold and hot water tap. The first thing you want to do, if you want to take hot water or you are running your bath and you want to put the water, you need to check the temperature of the water. How do you do this? You can't just say, oh, it's the hot water is coming out. Even despite that, the hot water, the hot water is running. But you need to feel the temperature. Is it the normal room temperature for you to use to take your bath? So you need to test it by putting your hands inside. So currently what you're doing is that you're just testing to see, okay, is this okay now? You put it on your body. Oh yeah, I think this is okay for me now. Let it maintain that temperature. That is what you are currently testing, what you want to do. Let's take, for example, you're cooking. You're putting your ingredient, putting salt and things like that. You want to feel, does this taste good? What you are currently doing is that you're testing. So you are tasting it. Oh, yeah, it still needs more salt. That's something you're doing again. You are still testing. You sleep in the evening or maybe when you wake up in the morning. The first thing you do is to stretch your body, move your hand, move your leg. What you're doing is that you are testing. You're trying to feel that, oh, Yeah, I can stretch my legs. I can. My muscles are still there. Yeah, that's what you're doing. You're testing. If you want to learn how to drive a car, you can't just say, "Oh yes, I can drive a car straight on." No. First, you learn, then you start testing if your driving skills is in place. Even if you know how to drive, you still need to be sure that yes, of course, you're testing. So all these are various things that you can put in real life scenario that you're testing. Like we have in some part of the like in Africa, if you want to buy certain food, you want to test it. Take one of the local food that we call cassava flakes. That's gari. Sorry. So for gari, you want to taste. Oh, is this actually the taste I really like? What you are currently doing in the market is that you're tasting. You're testing if the gari is something you like. So these are examples that you can use as a background for testing. So in every form, in every aspect of life, testing will always be there. There's nothing you want to do. You want to take a pen. You want to write something with a pen. The first thing you need to do is that, oh, is this pen working? You just scribble and just check. Oh, yes, the pen is working. What you're currently doing is that you are testing. So that's the same way. That is the way I can say testing in all forms. So there's different ways, different areas that you can actually say you want to test. But at this phase now, we are now taking testing into another part to say, oh, this is the background of testing. This is how it happens. This is how testing works. These are the nitty gritty. These are the things that you need to understand before you can test. These are the things that happens before you can test. These are your precautions. These are things that you should put in terms before you can start testing. So I'll take an example. Say for instance, you want to buy a new car. You can drive. Now you feel that, oh yes, I want to get a new car. The first thing is that you get to a showroom, you look into the showroom, you've got there, you've booked and you've gone there to check. You want to get there to see your brand new car or the car you want to buy. You don't want to see a dent car. You don't want to get there to see that there is no engine in the car. You don't want to see there that there is no door in the car because your expectations that I should get to the showroom. It should be a full package. I should have a car. The car should be normal. It should have four doors. If it's five doors, if it's five wheels, all the specifications that you've read from the manual, you want to see that same car come to life. So, hence, you are in the showroom. The first thing you want to see is that you need to test it. You can start the engine. Yeah, there is an engine in the car. It's got the five doors. It's got your wheels. It's got the horn. It's got the brake. It's got things, essential things that are meant to be in the car. And then you can put your money down to say, I want to purchase this car. So if you get to the showroom and you want to buy the car, he doesn't have any door or he doesn't have a steering wheel. How do you want to drive the car? Unfortunately, you can't. So these are kind of things that you look at when you want to buy, maybe you want to buy a car. So you will have to check some of it. And these are the things that here it says the car should have five wheels, a steering wheel, an engine, and all essential components. So if these are there, you can it's got your five wheels, it's got the doors, it's got everything that is written in the manual, that is written in your documentation. Then you can put your money down to say yes, you want to buy the car. But if you get to the showroom or you get to where you want to buy the car, is dent, is got accident, there's no engine there. There's no need for you can't put your money down on that kind of car that you want to buy. So those are the things that you check, and those are the things that we do when it comes to testing. So there are more examples in the textbook, which I'm going to explain, talk about it later. So I've just written the pages there. So, so some of the topics that we are going to cover today in this The topics we are going to cover are the fundamentals of testing, testing principles, the test process, code of ethics, testing life cycle, test levels, type test types, static testing, then test case design techniques, and test management. These are the topics we are going to go through throughout this manual testing courses. So I welcome you once again to the class. So also before I start up this, we've just looked at some of the roles that you get software testing. Oh, software testing. Of course, different roles is just mainly the names that can kind of different. We still do the same thing. So as a software tester, you can be a QM quality assurance engineer. That's a QA engineer. That's one of the role. UAT tester. You could be a test analyst, manual tester, web tester, QA. That's quality assurance test analyst. You've got functional testing, software test analyst. You've got agile tester. You've got automation tester. You've got system test analyst, security tester, performance tester. You've got penetration tester. So you've got wide range of testing roles, different roles that you can talk about when it comes to software testing. So we all do the same thing, but the thing you need to understand here is that before you can start testing, this is actually the starting point for you. This is the bed that you need to lay because you need to understand what manual testing is. You need to understand what software testing is. Then that's when you can start progressing to the next level to start doing automation, getting deeper into it. But you need to have a greater understanding of this. And so that's why hence in this class. So there are different roles you can talk about, and all this role fetch good salary rates, which I'm going to display on the next slide. So these are some of the roles that we are actually looking. There are still more. You've talked about mobile tester, so it could be a mobile test analyst. You can talk about pen testing, that's penetration testing. Security testing is the performance testing. Non-functional testing, tester too is there. So it depends on the kind of name an organization gives to the role. But you will know that yes, it's a software testing role. So then the next one is just software tester skills. So this is just like a skill level, just showing you that the importances of those skills. So take testing. So they've taken that testing on a large quality to tell you that you actually need that testing. You need that manual testing. You need to understand. You need to have this foundation. So hence, that's why it's on a larger scale to say, oh, this is it. This is the long bit of it to say it is compulsory for you to have software tester. Now we are trying to streamline the skills. We've got system testing. That's mainly on the system part of it. Test planning, all these are going to be part of what we are going to learn here. SQL is one of the database testing, that's SQL. Automation, that's something you're going to also learn within this course, and that will be intense also in the internship. So products and Microsoft Windows, all these are part of testing skill, software tester skills. So now just talk about the salary expectation as at June 2021. So the list, as in you get there are different range that you can do, and it depends on your location and wherever you are. I know currently if this is saying 48, 50,000, you get roles of 80,000, 75,000. So it depends on the skill set. So definitely there are different roles, good paying job. And if you look at this from July 2020 up to this time, despite the COVID and everything, you can still see the salary level for a software tester. This is a minimum. You can get even more than I know absolutely. Even more than 52, no, 75, 80. So it depends on what the role, what it entails, and what your job, what you have to do. But as a manual tester, you still get a job of 45, 50. But no matter the job you're doing, even if you're doing automation, there are still some viable place that you still need to do manual testing. So, yes, yeah. So after the also testing as a discipline. So just talking as discipline as a work, who is a good tester and what it entails to be a good tester and things like this are justice. So for a good tester, first is that verbal and written communication. Simple sentence, put your plight in just clear, precise sentence, and also for you to be able to communicate to people, for them to be able to understand, which we are going to, in terms of maybe you're raising bug, you found some issues, you need to explain steps to reproduce them. These are the kind of things that make a good tester. Then you should be able to explain, this is what I have seen. Now I've gone to the showroom, I want to go and buy a car. When I got there, it didn't have 5 doors. So you want to explain to someone that it doesn't have a door, there was no engine. Your explanation is, I've gone to the showroom. These are the list of the things that I can find in the car I want to buy. It's got no engine. I can't start the car. It's got no doors. So people can bullet point to see, oh, yeah, okay, we know the fault is here. There's no engine. There's no car. So it has to be both in written and also verbally. You should be able to communicate with people. Then passion. Whatever you want to do, you must have a passion. You must at least like whatever you want to do. Passion, technical skills. Hence, that's why you're here. You're also going, of course, the Java class has started, and also, so those are the technical skill set we are actually talking about. An analytical skill set, your attitude and productivity in terms of the end product after you've tested. All these are embedded as for a good software tester. Please, once again, any question you've got at any point in time, please ensure you put it in the chat. People are there to answer you. So these are the objectives. So we're going to start first with what is testing, how is testing done, why is testing necessary, general principles of testing, fundamentals of testing. Then there are assessment questions that you are going to have. So let's go. So just make it more beautiful, looking radiant, how testing is. So this is it. What is testing? Just mainly from the previous slide. Why is testing necessary? General principles of testing, fundamentals of testing, and self-assessment questions. So what is testing? We've been talking about testing, 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 testing. What it is. What is this? What is testing all about? This is an activity that is performed to demonstrate that something is working as expected. Something is working as expected. I've gone to I've gone to the showroom. I want to start the car. If I start the car and there is engine there, that is one tick. He's working as expected. He's got my 5 doors. He's got the 5 wheels. He's working as expected. I can drive the car. He's got a brake. That shows that something is working as expected. Now, let's give it the other way around. I've gone to the showroom. He's got no engine. He's got no door. He's got nothing. Then it is not working as expected. So this is an activity. The reason why we are testing, the reason why you want to know that this is, the reason why you went to the showroom, the reason why you need to test drive is to be sure that, yes, something is working as expected. So that's why you are always advised to test drive. I'll give an example. recently I've got someone that bought a car. She thought that the car was working as expected, and she tested. She went by to buy the car herself, but getting home, she only did the show when the person was driving. It's fine, because she needed a car quickly. And by the time she got to start to drive the car, it wasn't working as expected. Then called the number back. Unfortunately, no. So that means she's lost the money. She's lost the car. She should have tested it properly. And that is the reason why you should do proper testing before you can actually get purchase anything. So this is an activity that is performed to demonstrate that something is working as expected. As expected. That is what testing is all about, to ensure that it's working as expected. Testing for me, really? Oh, then let's find out. Testing as a discipline. For you to be able to test, you must be inquisitive, you must work smartly, you must think out of the box. I always say that there is nothing that you want to test that is not, there's nothing you want to test that is not in this world already. So talk about, you want to test, you are in an organization testing mobile phones. We've got 1 million, we've got billions of different mobile phones out there. It's just for you to have an understanding and know what you want to test. So there are various scenarios that you can use. Take a car. There are 1001 different cars that you can test. Today you have this series. By the next month another one is coming out. So hence there are different things. So you just have to be able to think out of the box. What are the things that is going to happen if I don't test properly? Those are the thinking out of box. You have to be patient. If you're testing it, it's not, as I've said, someone bought a car. If she was patient enough, she would have known that, let me drive it myself, let me have a feel of it. Then I will know that, yes, this is not working, because the owner of the car will know what is wrong with the car. So you have to be patient. You have to do attention to details. And this always gives me a reminder of when, if you go for an interview, attention to details is key. When I mean is paramount, is that you should look around you when you're going for interview. When you get to the organization, if it's a face to face, you have to look around. What are the things that you can see? Pay attention to everything around you. That could be one of the questions you're going to make, because when you are given a time to say your speech, your 5 minute speech, after talking and you're saying, oh, I pay attention to details, and you're asked the question, you pay attention to detail, what floor are you on? And you don't know, then you didn't pay attention to details. What is the color of the building when you were coming? You didn't pay attention. How many people were on the reception floor? You should pay attention to little details like that. So that really shows. So that's testing as a discipline. You must be inquisitive, work smartly, think out of box, patient, attention to details. Who can test? Anybody can test. It's not rocket science. Anyone can test. You can test now to feel if the room temperature of the water is fine. Anybody can test. As long as you can drive, you can test drive a car. As long as you want to use a pen, you can test it. So anybody can test. What can be tested? The two things that can be tested: hardware, software. Hardware are physical devices. The physical device, something you can touch and see, e.g., your laptop. Those are hardware. Software cannot be touched or seen, e.g., your internet browser, the games, the things behind it. So all these are what can be tested: hardware, software. So you could be asked interview question, what can be tested? Hardware, software. Physical device, something you can touch and see, e.g., your laptop. Something that you cannot touch or see, e.g., your internet browser all these software. So before we continue, these are just references of things that we do. So you can use this link. And also there are different materials online that you can actually learn from. So Guru 99 is one of it. You've got tutorial point. You've got loads of materials online. So you could just have a feel and look, just read and have a look at it. But these are some of the references that we just put here. Please remember any question again, just let me know. Then we can. So software testing. As I've said earlier on previously that what is testing? So now we are going to software testing. This is an activity that is executed to demonstrate that a software, it could either be a package, a program, a system, a product, a web application, a mobile application is working as expected. So you can see that we are still saying the same thing. You must ensure that it's working as expected. That is what it means that you are testing. You are testing to feel that, oh, is the water too cold or is it too hot? It must be perfect for you to use. That is it. You are testing, is the food sweet? Is it up to the standard of what I want to eat? You are testing that yes, it should work as expected. Hence, now we are putting it into practical terms that yes, is working a software, maybe a program, a system, a product, or a web application. Take for example a Google app. You're testing if it's working as expected. You've got a mobile application, just pressing your phone, going through some of the things, some of the features are there. Is that you're checking that are they working as expected? These are software testing is not complex. It is not difficult to implement, execute, and practice. Software testing is a discipline. Is a discipline. How can a software be tested? How can it be tested? So today you are in a manual testing class. So we've got two ways that it could be tested: manually and automatedly. So manual testing, test testers execute test cases without any tool. So you're not using any tool. That is manual testing. Like we're talking today, I've been giving you examples of what testing is like. What are the things that can be tested? What are the things that you should expect? What is the meaning of testing? So now, manual testing is that the testers are testing test cases without any tool. Just pay attention to some of the words that have been using right from the beginning of the course, because that's what you are going to. I always say they are like testing jargons that you have to understand them. Test cases are one of the key things, the necessary thing in testing. You'll get further so you understand where test cases are. So manual testing, testers execute test cases without any tool. Automated testing, a tester executes test cases with a tool. Manual without a tool, automation with a tool. So that's why you're learning the Java. All this will be explained to you in terms in the internship class. So this will be broken down for you. You have an understanding of what manual testing is and also automation. But before you can do anything, you're as long as you want to be a tester, you are in the right class, because this is the first place you have to lay this bed. You have to understand what testing is before you can now say, oh, you want to start automation. Then it will give you an insight of it. So that's why these are run concurrently. It's just for us to for you to have an understanding of it. So how can a software be tested? Manual and automated. Why do we test? Why? What's the reason? Why do we need to test? To avoid software failure. So now you want to be sure that, oh, this application, this website does not crash. You need to test it before you actually send it to um, to send it out to the public. So it has to be tested internally, vigorously, before you can say it's working as expected. To avoid software failure, a system needs to be adequately tested, and the right sort of testing needs to be done as well. So these also you will learn it as it's going, because there are certain stages and certain um, precautions and steps to be taken when you're actually testing. You don't just say, oh, because I've tested this, that this is working as expected. No, there are certain checks, some verification, validation stages that has to be taken before you can actually say, oh, I can beat my chest to say this is working as expected. And the consequences, if you don't test properly, what will happen? So what are the consequences? Loss of money, loss of time, loss of business reputation, injury, and death. So take for instance, you've gone to the car and you've tried the you want to buy the new car that we've been talking about, and you get there, you find out that, oh, the brake wasn't tested properly, and someone drives the car, gets an accident, and the person died. If proper testing or something like that has actually been done and put precautions there, then it would have saved that person or saved the life. Loss of money, the time, that the resources, the time, the people you've put to do that. These are consequences. Loss of business reputation. If an accident happens today to this car, to the same brand, all the time, I won't tell the next person. None of us will tell don't buy that car. You're going to, you will have an accident. So that's the way. So business rep will go. You will lose your customers and thereabout. There is a level of risk acceptable for any software. E.g., the way you would test an airline application is different from the way you are going to test a financial application, likewise an e-commerce application. So that's why I said the way you are going to test an application, it differs and it varies. So you are saying, for example, this um, the way you are going to test maybe a normal airline application is going to be different from the way you test a financial application or an e-commerce application. A financial application where you need to make payment, and so if people get online and they are not able to make payment and they are making all their shoppings, getting everything coming in, there'll be loss of business, loss of money for the organization. So the same way, so you need to test that place properly, verification, validation testing, do your normal regression testing. There are certain testing levels that will be discussed in this program. So now we move to these three: error, defect, and failure. Please, once again, any question, please just put it on the chat and we can actually, my colleagues will be answering you. And yeah. So, error, defect, failure. Error, defect, failure. An error or mistake leads to a defect, which can cause an observed failure. So, an error, it leads to defect, and the defect leads to failure. So, what is an error? Error is human mistake. Human mistake. An error appears not only due to the logical mistake in the code made by the developer. anyone in the team can make mistake during different phases of software development. So let's take an example that error is human mistake. It could happen at any phase. Maybe I'll give you an example of a typical team, how a team looks like when it comes to when you're working. You've got a business analyst there, that's a BA that does the requirement. We've got developers, we've got ourselves here, which are testers, we've got the project manager, we've got scrum master, we've got solution architect. There are different levels of it, but there are ways that things are meant to go. So there are structures that are meant to be followed. So if you have a document, you're reading through it, and there are mistakes there and they are not corrected, is whatever is in the document that people will develop on. And once they start development, then if there's a mistake in the document, then obviously you know that yes, there's going to be mistake in everything that we're going to do, both development, both testing, because definitely since there's a mistake right from the top and it wasn't detected. So, so let's say for instance, what are the levels? So they say a BA, that's a business analyst, may misinterpret or misunderstand requirements. So as I've said, a business analyst is also someone that gathers requirements, talk to the stakeholders, get information to the development team, just mainly like a link for us to understand whatever application or the software or the product we're working on. So if she misinterprets or he or she doesn't have a good understanding of what the application or the software is, then everybody that goes, whatever is developed, will be wrong. Also, the customer may provide insufficient or incorrect information. So if we get incorrect information, then of course, whatever development that is going on is going to be incorrect too. The architect may also cause a flaw in software. Then there could be unclear or insufficient requirements when it comes to um, when it comes to we when it comes to understanding and having a clear understanding of the requirements. Maybe the developer doesn't is not clear about what to develop, or also testing team and the like. So all these are different phases that you can actually get when it comes to error. So I'm just going to go back again. Error is human mistake. Remember, these three, these three, you have to understand it very well. Most of the time is always asked in interview. So maybe when you're working, when you're going for when you go for an interview, you get questions like this. So what is defect? Defect is inconsistency between expected and actual results. Another term here. Before I was using test cases when I was talking about how can testing be done, manual and automatedly. I said test cases. I mentioned test cases there. Now I'm mentioning expected and actual results. These are the terms that you're going to be using. Expected, actual result. What is expected? Expected, when I get to the showroom, I want to have my expectation is that it should have an engine, it should have a five wheel, a five doors, steering wheel. That is my expectation. That is what I'm expecting to see in the car that I want to buy. The brake must be good. But now I am now in the showroom, live in the showroom. I'm seeing the car I want to purchase. The actual result of what I am seeing currently, it doesn't have an engine. So this is what I am seeing now. It doesn't have, it's got a three door, it's not a five door. So that has to be fixed. Not a four-wheel. It's got no brakes. That is my actual result because I'm seeing the car currently. Expected is my expectation before I see the car. So this is my expectation. I don't know. I want to, if I really should have an engine. Actual result, I've not seen it, but currently I'm in front of the car in the showroom. This is what I can see. That is actual. So always have that at the back of your mind that actual results, expected and actual result will always come. Test cases. A defect is inconsistency between expected and actual result. A defect in a software product reflects the inability of the software to comply with the specified requirements subsequently. Prevent the software application from performing the expected work. So, a defect in a nutshell in that car is that I've gotten there. I can't start the engine because it doesn't have one. So, that's a defect. It's not working as expected. So it's not performing what is expected. So that's the defect. So it's not doing what I'm expecting it. My expectation is not doing it. That's the defect. You've tried the pen. The pen is not working. When you wanted to use the pen, you scribbled and scribbled, it's not working. So definitely it's a defect. It's not working as expected because I can't use the pen to write. So these are examples of defect. If I've gone to a website on Google, an e-commerce website, I'm trying to add a product into my cart, and I've done that subsequently. My internet, my browser, everything is working as expected, but for this, it's not going through. That's a defect. I can't add it to the shopping cart. So these are defects. An error that the tester finds is known as defect. The defect is also known as fault or bug. So now people call it different name. You can call a defect a bug. Some call it the native, those that have been doing testing for maybe longer, they call it fault. Some call it error. But an error that the tester finds. So if you find a mistake in whatever they have built, is called a defect, and a defect is also known as a fault. So what is failure? Failure is a consequence of a defect. So now I've found it is not working as expected. So what does it mean? It means it has failed. The car is not doing what I'm expecting it to do, so it has failed. I found a mistake, and the mistake is that there was no engine. I found an error, which is a mistake. There's no engine. I can't start the car. That is the defect. That is a bug. Now, that bug shows that, yes, this car, you have failed. I can't buy you. That is what it means. So that's why they say an error leads to a defect, and a defect leads to failure. So it is observable incorrect. It is the observable incorrect behavior of the system. Failure occurs when the software fails to perform in the real environment. What is the real environment? You've got a product, you've got an application, and it's not working as expected in the real environment. Then you will know that yes, that is the that is a failure. This is not working as expected. Then it doesn't match what you want. So the real environment is where exactly you are testing this one. If you are testing maybe your e-commerce site on your website and it's not working as expected, that is your real environment. We have different test environments, which you are going to get an understanding of it later in the course, and also in depth in depth about it in the internship. So this there are different levels of test environment. You can get an organization that you've got 5 levels. So you're talking about maybe you've got test environment, the dev environment, test, you've got integration, you've got system, you've got UAT, you've got pre-prod, and you've got production. So there are different test environment, and everything mirrors differently. It works differently. There are different configurations in those environments. That you will get an understanding of that in the internship. In other words, after the creation and execution of software code, if the system does not perform as expected due to the occurrence of any defect, then it is termed as a failure. So these are just more examples just telling you what it means as a failure. Not all defect results in failure. Some remains inactive in the code and we may never notice them. Any question, please put it on the chat. So before I go, I'll just ask a quick question. If you could just type it on the chat. What is error? What is a defect? And what is a failure? Quick chat. I'm just going through it. Anyone helping? What is error? What is a defect? And what is failure? Any answer? Someone asks, what about bug definition? Bug is a defect. That's why I said you could call it a defect. You can call it a bug. It's just like it having different names. So anyone helping? What is yeah. Failure is the application that yeah. Thank you. Someone said failure is when the application does not perform. Yeah. Let me help. Okay. Error is human mistake. Absolutely correct. Yes. Thank you. That leads to defect. Yes. Error mistake leads to defect. Yes. So anyone doing defect? So I can know that yes, the class, everyone. Yeah. Okay. Thank you to everyone. Thank you. Yeah. Okay. More coming in. Let me see. Error does not occur during code. Yes. Defect is an error found by a tester. Absolutely. You've all answered it correctly. Well done, well done, well done. So you're all following me. Well done, class. Well done. So then the next stage we are going to, so I've said error, defect, and also the last question, how can they be tested manually, automatedly? So that's the first phase. So let's just keep going, keep software under control. So there are these that you can keep your software under control. So first, exhaustive testing of complex system is not possible. So now that's where we start all about testing. I've been saying that there are different ways you can test. There are different things that need to be done before you can start testing. So what is exhaustive testing of complex system is not possible. So for instance, you've been given an application. They said, oh, let me take example of that same car that we have been working on. That you've got in your car. You've been, oh, yeah, me test this car. And you've tested the car, you've test drive it, you've gone all around with the car. And oh yes, you can't beat your chest to say if someone is driving recklessly or is driving like 150 miles and you're driving so fast that the person won't have an accident. No, you cannot. So you can't beat your chest to say that yes, You've done that, that nothing will happen to this car. If anyone picks it, even if you drive recklessly, nothing will happen. No. So that's why we say exhaustive testing of complex system is not possible. You can't, if you're given an application, say for instance a website to test, you can't say, oh, there will be I've finished testing, there will be no failure in the website. You could have configurations failure. You could have some bugs slipping through. So these are part of things that we need to understand, and that is where prioritization comes to in place when you are testing. Prioritization. So you have to prioritize how you want to. In the morning when you're going out your day, you know how to prioritize. This is what I want to do first. This is the next level. After I finish taking my shower and done this, I'm going out. The first thing I'm going to do at my workplace, these are the things. You lay it down. You've got your routine. The same thing with testing. There are stages that we need to start with. Oh, I've prepared my test cases. I've started test execution. These are the things I've done. These are the yardstick. I've done my traceability matrix. I've mapped it with the requirement document. All these are expectations that are meant to go. So is it possible to run every possible test, simple or complex? It's not possible because you can actually run all your tests to say, oh, I've finished running all these tests. It's absolutely fantastic. You can't beat your chest on it. No. Someone else can take it. Let me give you an example. If you have a page, maybe you were given a textbook to read and you finished it and look for the errors that are there. You are proofreading. If you are given, if I'm the first person that they give the book to me for me to read, I go through the book. I've done everything. Look for all the mistakes. Maybe like is spelled TEH. I'll get those ones, wrong spellings, different things. I've done it, and I say, oh yes, that is fine. This book is working as expected. I can bet you that after I've tested, if you give it to another person, he's going to find maybe another 20 errors in that same book. If you give it to a third person, that same thing, he's going to find his own error. Subsequently, if you give it to people, they will definitely find their own errors there. So you can't say, yes, you finish, nothing is going to happen. No, there are still errors because the more you look at a particular thing, you will not see any error there again. You won't see any mistake there again. So that's why we say if you're testing, you wait, you have to be patient, maybe leave it for some time, go back to it again, you see another error there. So those are steps to be taken when you're testing. It is if every test has been run, testing would go on for a long time and product may never get into the market. So let's take an example. If you say, oh, that car, I want to keep testing and testing the car so that the brake will be good, or so that it won't have an accident. This is the way I can just do it. I need to test this car vigorously. Believe you me, if you're testing that car, that is, the way the cars are being, you've tested for 1 year. Another new version, the new model of the car is out again. Before you finish testing in 2 years, they've got like 3 to 4. So who is going to buy the old one? Nobody is going to be. So that's the way it is. So you can't say you have to run all possible tests so that yes, I can say this is done, then you can put it in the market. It's going to waste time. So people won't have them. So those are precautions also that we are going to put in place. With large and complex system, it will never be possible to test everything exhaustively. In fact, it is impossible to test even moderately complex system exhaustively. So these are just an example of you to just have it in back of your mind that it's not that you are going to test the whole system, but there are testing level different phases that has to be carried out for you to be able to do that. You're going to learn that in the course and also more intense when it comes to the internship. So when is testing enough? So I've been talking about it, talking about different levels, talk about exhaustive testing. When is testing enough? So these are two words that we put in place: testing and risk. When you are testing, you are looking at the risk. Testing, you're checking the risk. As I'm testing it, what is the risk? Those are the things that you have to weigh. Is this dead? Will this cause an injury? Will this cause death? What are the things that is going to cause? Loss of money, business rep. All these are things that you weigh when you're testing. You're testing, you should weigh the risk. So those are the things that you put in place when you are testing to know whether testing is enough. So also you are testing and looking at the quality, not because you want to test, you want to put it in the market. We also have to verify the quality. Does it meet the user expectation? Is it going the right way? Is this what the user expecting? These are things that we put into consideration when we are testing. Testing quality, testing and risk. Then decide when enough is enough. When do I want to say enough is enough? When do you want to say it? How do you say that? Yes, I've finished testing. These are the things that we compare and to say when testing is enough. The first thing, as you're testing, you'll be testing thinking that what is the risk? Not to forget, all this would have been tabled down. As I'm testing in my test cases, you would have been putting your both your negative and your positive and your negative scenarios together. Is working as expected? If it's not working as expected, what are the possible risks? You will have to be testing those in parallel. Testing and quality. What is the quality? Am I testing? What is the quality we are giving to the user? Is it working as expected? Is this the right search button? Is this the kind of login that they want? What is the quality? How is it? Deciding when enough is enough. Have I tested? Have I prioritized? What are the things I've looked at? What are the things that is needed? All these are the things that we think of when it comes to testing, for you to know when testing is enough. So when you're asked, how do you decide to know when testing is enough? When you've tested, when you're testing, you testing and you verify, you check the risk, you testing and the quality, then you can decide is enough. Enough is enough. What are the general principles of testing? General principles of testing. So we've got 7 general principles of testing. Testing shows the presence of bug. Do you all agree with me that testing shows the presence of bug? If you did not test your car or test the pen that you want to know, you won't know if the pen is not working. If you do not test the car, you will never know if it doesn't have an engine or that. So that's why I said testing shows the presence of bug. So for you to test, you are actually testing to make sure that yes, the bugs are kind of visible. That is the reason why you are working as a tester. You must be able to get to look for the mistakes before this product comes out. So once you're testing, you have to be sure that yes, you are looking at all the scenarios, validation, looking at is this working as expected? If it's not working, you escalate immediately and let people know that yes, this is not working as expected. So testing shows the presence of bug. Exhaustive testing is impossible, and that's what we said in 2 slides before now. So it's impossible. You can't beat your chest to say, I've finished testing, nothing is going to happen to this. So no, it's impossible. Early testing. What is early testing? Early testing. If let's take an example of the car. If they've started testing early, when the brake or when the engine is in, you've checked it, you've tested, that is kept. Oh, This is working as expected. You keep it in one side. You've checked the brake, it's working as expected. You keep it another side. You've checked this, it's working as expected. Then you can now integrate and put everything together that is tested. Then you now do the overall end-to-end test to show that yes, all these things have been integrated together, they're working together, they can drive, you can move the steering, you can move that. Take an application like um, a normal website application. The first thing is for you to have an access to the website. You need a login mechanism for you to be able to log in. You need a username, a password, or you can register. Those are for the first time user. So what are the things that you need to do? So if early testing, if you started, maybe the first thing that the developer did was to build a login, and you as a tester come in immediately, you've written your test cases, you've designed it ready for execution. Immediately they do the login, you start testing. You test different possible combination of of every scenarios to make sure that, oh, is this a valid username, is this an invalid username, is this what happens to invalid password, what happens to it if I don't put any password. Those possible scenarios, if you start testing that early, then it gives everybody an insight. We know the mistakes that are going to come. Then that's why we encourage early testing. So as they finish building the login and everything is working as expected, that code is kept somewhere. Then the next thing, you go to the next one, search button, you can land the page, you can navigate. So these are the way things are being done when it comes to um, early testing. Then defect clustering. There are places that defects are being clustered, different types of defect. If you know what defects are like bugs. You're finding different mistakes. So they are that is what um, defect clustering is. Then pesticide paradox. So what this means is that, as I've given you an example, say for example, you are reading through a particular textbook and you've been given that, oh, Yemi, you test it first. I've read through it. Oh, there's no mistake, and give it to tester B. Tester B has gone there. He's found another 30 bugs. Tester C has gone there too, has found another 40 bugs. Tester, so it keeps, but this pesticide paradox, what it's trying to say is that the more, even if you read, if I look at it, because I'm the first person, if I keep looking, keep reading, I will never find any error. So it doesn't mean that, yes, that this is working as expected. No. So it means that you just need to be careful, just be patient, think and look through, follow the process and ensure that these um, the application of the software is working as expected. Testing is context dependent. So, for instance, you can't test without you having something. I can't just be saying, I want to test, and I don't have anything to use to test. So it is context dependent. So you can't, like now, you want to test a mobile phone, you want to test a mobile application. You don't have a mobile phone, you don't have a laptop to test. So how do you want to test? So it needs something. So you can't test alone. You need something to test. And in testing, when you are testing, there are things that you need to put in place. Let's say, for example, you've written 5 test cases, you've designed 5 test cases. Your manager can come to you to ask you, oh, how many test cases have you done? Oh, you say, you've got 5 test cases. Oh, have you executed them? Yes, I've executed them. How many passed? You can't say 3 passed. We know 3 passed, but you have to put it in percentage. So you say 60% of it passed, 40% failed, or maybe 20 failed, 20 blocked, or 10 blocked, any ratio, or 60 failed. So that gives people an insight of what the yardstick is, what we need to do. Um, there are there are different I'll say there are different yardstick that you use in different organizations. Some places might say when the 80% of the test cases or 90% of them, 80% has passed, and if or all the priority bugs, the P ones of your test cases are executed and working as expected, yes, we can let go. Then we can be doing the cosmetic ones, cosmetic bugs. Maybe you want to fine tune it to make it look more beautiful, colorful. We can be doing that later. So all these are things that you put into consideration. So you don't say 5 test cases. You have to always put it in percentage because it's kind of easier for people to have an understanding. Even if you say you've written 500 test cases and you say 329 failed, 329 passed, people will be looking at you. But if you say, oh, 70% passed, it clicks quickly to people than that. Then absence of error fallacy. So this is what we are saying is that you can't say, oh, there is no error in this application. Oh, I'm a guru. I've finished testing. There's no bug. No, it's impossible. So these are general testing principles. There's 7. Testing shows the presence of bug. Exhaustive testing is impossible. Early testing, defect clustering, pesticide paradox. Testing is context dependent and absence of error fallacy. Please, any question? So before I continue, quickly on the chat, just give me like three general principles of testing. 3. You could just type it in the chat quickly. Anyone, anybody to help? Just 3. The one we've just done, just the slide. Quickly. Early testing. Thank you. Thank you, Tim. Thank you. Pesticide paradox. Absolutely. Thank you. Error fallacy. Correct. Thank you. Thank you. Thank you, everyone. So, yes, I can see you're following. So, now that is it. Thank you. I can see. Yeah. Thank you. So, now we go to fundamental test process. So, this is a fundamental test process. So as we are going along, all this, just the words, just have them. Everything you will always see test in front of it. So you will know that it's all about testing. So there are 5 of them. There are 5 categories. So I'm just going to use a house. Let's say I'm going to use a building as an example for this. So let's say a builder wants to build a house. He can't just get there and just start building straight on. The first thing is we need to do the foundation. Ensure that the foundation is solid. After the foundation, then he start putting some blocks. He would have done before the foundation. He would have done his own background checks in terms of design, what type of tools, what type of things are going to go on the floor. Then the next thing, he starts with the foundation. After the foundation is concrete, then start building the block. After then, they put a roof. After the roof, then they'll start just finish the old decor and the house is in shape. Now I'm using the same tree as fundamental test process. What are the first things that we do when it comes to the different levels that we take before you start testing? So the first thing is testing and planning. Test planning and control. Test planning and control. You can be asked this in an interview. Like I've said, testing principles. There are 7. Fundamental test process. There are 5. So the first one is test planning and control. Test planning and control. How is test planning done? You start designing. Start looking, what are the things I want to do? How do I want to carry out this? We start with writing our test plan. What are the things that we want to do? What are the type of testings we want to do? What are the things that is going to be done? So your normal prep, you need to understand the kind of testing, who is going to do this, the manual, the automation, all this will be embedded in your test plan and also your test strategy, just to get a control, to understand that these are the phases, these are the things that you're going to do. So you start planning. That's the first thing. Lay your test plan, put whatever is going to be the type of testing, what is in scope, what is out of scope, your um, the design structure you want to use, the type of testing you're going to do, your entry and exit criteria. All these are part of the things that you're going to lay down in your test plan. So the second one goes to test analysis and design. Analysis and design. The first one is test planning and control. Planning. Now, like the builder, he has started looking, what kind of plan am I going to put in this building? This space is small. How are we going to fit it? That's what the developer is thinking. I, as a tester too, oh, this is this is a web application. Where am I going to come from? What are the things I'm going to do? So that is your planning. That is your thinking, and start putting everything into writing, into your test plan, into your test strategy, how you want this to look. Then the next thing is your analysis and design. What are the phase that you want to, what are the foundation that I want to build for my analysis and design? I start developing my test cases. So my positive scenarios and also my negative scenarios. So I'll start putting those in place. So now these are the test cases I want to execute. I want to start writing it. So I've started designing them. So that is where my analysis and design are. Then the third thing is the implementation and execution. How do I want to do it? How am I going to implement it? How am I going to execute it? So these are the things I want to do. I've got my test cases. I've got 5 test cases. Now I want to start executing it. Is this working as expected? Yes, it's working as expected. Then I'll start executing it, looking at it with the website. So that's my test implementation and execution. That is your third phase. So now you have seen it, you've done the foundation, you've started molding it up. So that is your implementation and execution. So now the next one, the fourth one is evaluating exit criteria and reporting. Exit, I'm going out. So now I've done my test planning and control. It's been approved. I've done my analysis and design. I've laid my bed. Then the next thing is I'm trying to execute it, test implementation and execution. So now I've started executing it. Now the fourth thing is that I'm trying to say this is it now. I've stopped. I want to start. I've stopped. That is my exit criteria. This is where the testing is. I've executed it. These are the things I have. 80% has passed. My priorities are these. These are the these. These are the leftover bugs. These are all this. All the reporting skills. So you have to put that, oh, this is what you've executed from your side, because you need to sign off. Let me tell you, the way a tester is, you've got mended the power. If you say no, it's not going to go out, that you've got this bug is a critical one, then it's left for them to decide. As long as I don't put my name, if I know it's something that I know is going to bring, is not going to go well, I'm not going to sign off. I won't put it. Someone else can actually sign off. Then the person that signed it off will be liable for anything that happens at the end. So evaluating exit criteria and reporting. So you've said, oh, this is it. This is what I've tested. Reporting, you want to put everything in place to say this has been executed, 80% of it. These are the bugs. These are the metrics. Just all your metrics, putting them in place. That is evaluating exit criteria and reporting. Always remember this word, exit criteria. There's also entry criteria. Entry, I'm coming in. I want to start testing. That is entry. Exit, I want to stop testing. So they are mainly English words that you could derive the answers from the name. So just know that it still means the same thing. Entry, I'm starting. Exit, I'm finishing. Then the last one is test closure activity. Now we're finished. I've given you all the report, all my metrics, everything is as expected. Then you need a test closure activity. I call it a test completion report. That's what I give as mine. So what I do in the test completion is just to say XYZ are my metrics have been done. These are the things I've followed. Just a 2-3 page, and I put it there, and I get a sign off from the project manager, from everyone, that the stakeholders, just to say this is it. This gives me like a contract to say you of all agreed that this is working as expected. Thank you. So when you come to me, what have you done? I just tender my completion report to say this is it. So when a builder finished building the house and he sees that all the electricity, everything is working as expected, you that want to buy, it gives you an exchange of contract to say thank you, welcome to your house. So I also will thank you, welcome to the product. So that is it. So before this is that fundamental test processing has 5 levels. The first one, test planning and control. The second one, test analysis and design. You can see it's hierarchy. He's got different levels. Test planning and control 1, test analysis and design, test implementation and execution 3, 4, evaluating exit criteria and reporting, 5, test closure activities. Any question, please put it in the chat. So, before we go, can let's see again. Let's try. Who else can you say? Just give me the 5 levels of fundamental test process. Just in the chat. Let's see. While we look down in the chat, does anyone check the? Thank you. Thank you. Test planning and control. Who else is helping? Implementation and execution, absolutely. Thank you. Test design and analysis, thank you. Closure, absolutely, thank you. Last one, thank you. Yes, that's the 5. So I can see you all are absolutely good students. So yes, so we'll go to psychology of testing. So a variety of different people may be involved in the total testing effort. So this is just telling you that we've got different people working in, we all work together um, as as one team. So in depth of this, you're still going to go through what we mean by early testing is going to go further. So you're talking about agile, waterfall, different kind of methodology. But here now, we're talking about who you're going to be working with as a team. You can't just be tester, just start testing. No, some people it starts from somewhere. So there are different people involved in the total testing effort and even as part of the team. As I've said earlier, we've got a project manager, we've got a scrum master. When you're working maybe in an agile environment, you get a scrum master. You've got a business analyst, that's the BA, in terms of requirement gathering, in terms of meeting the stakeholders, in terms of we understanding as part of the development team. So the business analyst has the key thing there to relate to us what they want or what the application or the product or the system we are actually working on. We've got the developers. So developers are people that are going to develop the system. We didn't just start testing. Someone developed before is now giving that to us. Maybe prior to the developer, some places that they do have a solution architect. Then it depends, like insurance organization, investment, even fintech organization. They do have data analysts, and I think there are some courses here too also. So in terms of the data integrity and things like that, you have people too on board. So we've got data analysts, we've got developers, we've got testers. That's we that we are going to test, and we've got yes, we've got testers, developers, every one of us in the team. So once we get the requirement, various people that start testing for us. When you get the requirement, the business analyst will call us as it to say these are the requirements, this is what the client is talking about, this is the system you are going to work on, this is what we want you to be. He or she needs to relate to us, to let us have an understanding. We ask question. If I don't understand what he's saying, I'll ask my question. If he or she, the business analyst, cannot answer the question, it takes it back to the stakeholders, look for different possible scenarios and bring it back to us. Then we agree on a particular way of the development. Same thing. So there are different people. So we start first by reading the requirement document. Once the requirement document is faulty, forget it. Anything that is going to be built, there's going to be errors there. So it's just like once you say from the head something is wrong, then there's going to be fault in everything that you're actually testing. You are doing even body development and everything, there will be fault there. So these are different levels. So we all have different things that we are doing part of the team. We all form one big team. And that's why we are all in one team. We can't work independently. We have to work together as a team. So if there's no project manager to actually direct us to bring everything to shape, then there's no how we can have a team. If there's no business analyst, who is going to gather the requirement? Who is going to speak? Who is going to give us information? Then he or she cannot also work alone. If when that requirement that the business analyst has gathered is sent to the developer needs to understand when the developer builds it, he needs someone to test it. Because when you look at something, as I said, even when the developer comes to you, we are used to it. Developer will tell you that, oh, it's working as expected on my system. But believe you me, when it gets to test the environment, it might be broken. It's not that, don't get me wrong, that he didn't do his work well. No, he did it. But all these things vary. That's why you are there to test your own bit. So that's why those levels are there. So there are a variety of different people may be involved in total testing efforts, and they may be drawn from a broad set of background. So, I've used an example of you reading particular a content, a book all the time, you will never find an error. You will never find any mistake again. But when you call another person, a neutral person, to just come pick that book, he can find another mistake. Call another neutral person that's read and we have corrected the ones this other person have done. The third person will still find his or her own mistake. So it will keep going that way till we get to a particular perfection. So some of the people that can be involved in testing, some will be developers. Before a developer gives you his code, it has to be properly tested and maintained. So once that is tested, it gives you an overview. The developer a confidence that, oh yes, it's working as expected for me, for him as a developer. Then he can now put it out in the test environment where you and I are going to test. Then some professional testers. So testers could come on board also to help to test in different levels, different phases, because we've got different phases when it comes to testing. We've got the way he's got, some people will do sanity check, smoke test, you do your regression, you go retesting of bug fixes, you do your functional testing. You've got different types from the user perspective, you do everything, you do your UAT. So all these are different test levels that come, and some will be specialists. So specialists, um, for instance, if you are working with a mobile, maybe you're testing a mobile application, the first thing is that you've got people that use mobile apps so much, maybe they know about that application. When they pick it, they can tell you all the errors there. So people like that can be brought on board also at the level to also come and check. We do some feedback session, such as those doing performance testing. So performance testing skills. So when I mean performance testing, we are talking about the load, the stress, the volume testing of it. Take for example, like um an application. Even use social media as one of an example. In social for social media, all of us could be using Facebook or WhatsApp at the same time. So we might be millions of people using it concurrently at the same time. We want to test to be sure that when that load is on the um, when we're all using it together, what happens? Does it crash? Well, all those tests are things that you do when it comes to performance testing. How many people can use it concurrently? What happens? How are these measured? You can be seeing this. You could use tools to do that. All these are things that you're going to go through when it comes to the internship class. So you have more insight to this. While others maybe user draft in to assist with acceptance testing. So you can get other people also to just come and do some acceptance testing in terms of validating, verifying, looking at look and feel. Does this meet the expectation? You said username. What is the username on your login page? If I put AYO, if I put this, different combinations and permutations that you could use to test just login scenarios. I can bring hundreds cases when it comes to testing login scenarios. So you just need to put those things into your test cases to be able to get that. So all these can be drafted. So these are mainly the kind of test levels, I mean people that can be drafted to come and help with testing in terms of them in testing. So I'll just go back. I'm going to just iterate on some of the things that we've done previously, and let me know if you have any question before I recap. I'm just going to go. It's common practice that other developers in organization also test before outsiders. Yeah, yes. So yeah, so if you have any question, please just post it, I'm sure. And thank you so much, man. You can see my colleagues are really helping out with the answers. The testers are complaining. Okay. Mhm. So that's why I said, you see, in yes, it is common practice that other developers in an organization also test before the outsider. Yes, before any developer before developer can give you his or her code to test, he or she would have tested properly. He would have tested properly in the dev environment. We all have different environments, and they are configured differently. So the way a developer's environment is configured is different from what is in the test. Is different from what is in integration environment. Is different from what is in system environment. Is different from what is in UAT environment. Likewise, prepared um, and also production environment. Production is mainly the life environment. When you hear pre-prod is a mirror of production. So what it means is that before we make it live to the public. Before we switch it to the public, we need a mirror. Mirror is just you looking at yourself in the mirror and seeing the replica of yourself. So the same thing is what is in pre-prod. So pre-prod is just an example of what is in the production environment. So those are the levels. So I'll just go back and we'll look at some of them. So before, so I'll just ask, what is testing? I'm sure people, if you could remember, I've said, what is testing? This is an activity that is performed to demonstrate that something is working as expected. So that's the reason you're testing, just to ensure that yes, it's working as expected. Then it's testing for you. So it's testing for me, yes. So the things you should put in mind when you're testing is you have to be inquisitive, work smartly, think out of box, patience, attention to detail. Attention to detail, once again, I know I can remember, and someone here to also remember that I've gone for an interview that is a big flaw, lot of flaws in the interview. I got there pretty much, so I've looked around. I just figure out some things, just look at the building, see what is there, and so you can't go into the building. Someone has to come and get you from outside. So by the time the recruiter came to get me and I got in, you can't touch it. Everything is modern day technology. So you have to touch the screen for you to use the lift. Ends. So and I entered into the lift. All this were not done by me because I don't know where I'm going to. Someone came to pick me. I wasn't told anything. So the only thing was just for me to be just to be paying attention. And while you're in the lift, you're also chatting with the recruiter. So you have to. He could be asking questions, where you're coming from, and the like. By the time I got to the floor, I just quickly looked at the floor quickly, and I went in. So of course, that's my first time in the organization. I don't know how their things are done. I got into that room and I've got four people there, and I'm just there to start talking. And so sell yourself. Of course, that's my 5 minute speech, and I'll put it there that I pay attention to detail. So he smiled, asked me most of the questions that I needed to ask, and after then, he said, "Oh, fine." When he found out that he didn't have much again, he said you pay attention to detail. So where exactly? That's the question. He didn't want to give up to say he's going to give me the job or not. He said, "You pay attention to details." I said, "Yes, I do." He said, "Okay, where is the flaw that you're doing this?" I thought first. I said, "Do you mean the flaw?" Oh, he said, "Yes, where are you now?" And I gave him the flaw. And he just shook my hand. I just said, "You pay attention to details. That's the only thing I wanted to know. If you didn't get this, you won't, maybe everything I've even said, even if I've gotten it, I might not." So that's your speech. You have said attention to detail. These are little questions that we take for granted. So we just need to actually, because in a team, you see, in a team, how many testers can work on a page of a website? Well, good question. In a team, it depends on how big your organization is, and it depends how we measure it is with developers. Sometimes it's ratio 2 to 1 or 3 to 1. So 3 developers, 1 tester, or 2 developers, 1 tester. But if it is more than, when you have 4 developers, if you've got 4 developers, then it's advisable for you to have um, 2 testers, 4 developers. Reason being that you are going to be testing these 4 guys will be working differently because they've got each of their piece of work, and you have to test them. So that's why it has to be, you can still juggle between 1 2. So if he's finished his own, you can test it. By the time he's fixing the bug, you can be testing the other person's own. So it's always good 2 to 1 and or 3 to 1. So developer 3, 1 tester, or developer, 1 tester. Once it's 4 developers, the workload is kind of much. But as I've said, it depends on the organization you're actually working with. So um, I'll go back again. So we can test. What can be tested? What can be tested? Class, hardware, software. What's a hardware? Physical devices that are something you can touch and see, e.g., laptop. And software are things that cannot be touched, like internet. You can't see what is inside what is inside your internet or inside your cables. You can see them. So all these. So software testing. We talked about explanation of software testing. This is this is an activity that is executed to demonstrate that software or a package, a program, system, product, web application, mobile application is working as expected. So software testing is not complex. It is not difficult to implement, execute, and practice. Software testing is a discipline. So you can also you could get a job role to say software testing. We are looking for a software tester. So that is a discipline. So how can how can a software be tested? Manually, automatedly. So for manual test, tester execute test cases without any tool, and automatedly a tester execute test cases with tool. So i- there's always something you should have in mind is always there's always um, a positive and a negative scenario. Positive, negative. So there's always something you can do and without. So without a tool, manual testing, with a tool, you see automation testing. Let's complete the study. Uh, the syllabus expects us to complete the study in 16 hours. How flexible is that? So that's the syllabus. That's the way you can study. Of course, it depends on how you grab and how you understand. But for us, these are kind of you are when you're talking about it's not only manual testing. You're also going to do automation. The syllabus that you're looking at that is saying 16 hours, 7, of course, practically in less than a day, you should be able to have an understanding of testing. With everything I've been saying, you will look at it that so practically everything I do daily, whatever you do in a day, you are testing. For you to, if you want to jump or you want to climb a curb, you'll just be careful. You're watching. You will watch your step. You are testing. You are looking at it. So those are so they are for that. I think mainly the expectation is that please can you put the reference on Telegram? Yeah, I will. Okay, that's fine. We'll put that there. We'll put that on Telegram for you. So the reference, there are also other tools that you can actually use to do that. Just Guru 99, testing tool, tutorial point, I think W3 schools. There are a lot of tools that you could use just to execute that. And the textbook, please. Yes, we'll send a soft copy. If you need a soft copy of the textbook, I think just speak to the admin. You'll be sent the soft copy of the textbook. Mhm. So, okay. So, how can software be tested? Manual and automated. So, also, why do we test? Why do we test? To avoid software failure. um, if a system is not tested adequately, there are things that can happen. These are the consequences: loss of money, loss of time, loss of business reputation, injury, and death. So that should be at the back of your mind. And hence, that's why I said when you decide testing is enough, is that you testing and the risk, um, testing and quality, then you decide when enough is enough. So after doing your prioritization, So error, defect, failure, as I've said, error is human mistake. It can be caused by anybody. So we are all part of a team. Nobody, you can't say solely that's someone. If the system or anything fails, it goes down to everyone within the team. So is we are all in the team to achieve a good goal for the organization or for the company you're actually working for. So that is it. Is human mistake. That's error. Then these are the different levels of errors. So we are just saying these are the people that these are where the errors could come at different level, either from the business analyst, from the client, whether from the customer. If there's no insufficient information, I see these customer insufficient information is kind of very common because, and that's why we are agile. You see different changes at every time. You have an understanding of that when the time comes. Then the architect also can make a flaw in the design. It could be anybody. People can be tired, time pressure. All this could cause an error. Then also um, a defect is inconsistency between expected and actual result. Expected, my expectation. Actual result. This is what I'm actually seeing as I'm using this system now. Is it compulsory to have a certification to be tester? To be honest, it's not. I can't say it's compulsory, but to me, it gives you, um, it gives you the confidence that yes, you have. Most of the time when you're working, they'll tell you, Are you ICEP certified?" Yes, you have it. If you need a certification, you might not have it, but it's just advisable that you do the certification. When you are in the internship, you are going to get a lot of help with that. I'm absolutely sure you will pass it at once for the certification. You'll have a lot of help when it comes to internship. We are going to give you materials, um, things to go through, so you've got everything covered. So for the just the certification is just 40 questions objective, and you're going to have more than that word for word. So it's kind of, yeah. So that's it. So we just said an error that the tester finds is known as a defect, and the defect is also known as a fault or a bug. So a bug is also called defect. Like we you'll be hearing us call defect management. Defect management. These are defect tools. These are tools that we use in recording. So, but we call bugs. Some places you call it bugs. Some call it defects. Some call it fault. So it depends. So failure is the consequences of a defect. So as I've said initially, so it is the consequences of a defect. If you find a mistake, that's an error. It leads to a defect, so which means it's not working as expected. And once it's not working as expected, it doesn't meet your expectation, which is a failure. So that's the way it is. Then keeping software under control, that's exhaustive testing of complex system is not possible. So the question is related to Scrum section. In every sprint, does the team have to follow the software development lifecycle? So for 5 sprints, they would have gone through five as a yes, it depends. It depends on the kind on the team, and it depends on how your sprints are run. If you're talking of 5 sprints, some are run fortnightly, which is the expected rate for when you talk about Scrum. So I think we've got the Scrum session here. So it depends on it depends on what you have in scope of for that. I think that will be it. So you can't say 5 sprints. I've seen sprints up to 20, up to 30. So it depends on how the sprint session is. And we follow, yes, you have to follow all these rules. You have to follow the software development life cycle. That's the essence of a sprint. It has to be. So it depends. But not everybody, the way you practice, the way this agile coach and also the way they're preaching agile, it depends on the organization and it depends on how people term it. So yeah. Is it possible to run every step simple as possible? So these are kind of you just saying, just ensure you prioritize, look at the nitty gritty of the test you're going through, ensure all the testing phases are taken. You've done your sanity checks, your smoke test, you've tested in all environments, you've done your acceptance testing, your regression, retesting of bug fixes, all the necessary processes that is in your test plan. You would have taken you should have gone through them. So when it's testing enough, it's just these are just to let you know, as you're saying, testing and risk. You are testing, you have to be checking the risk. So once I do it, if I've paid, maybe looking at an e-commerce or if an e-commerce site where you have to pay for your this thing. Once you've tested and you be able to add everything into your cart, you have to check that the money is actually going out and is not being cloned. All this you have to look at the risk. If the money is not taken, what happens? How is this being recorded? Also, you have to look at testing and the quality. What are we giving the users? Is this as expected? So you have to look at that. Deciding when enough is enough. Have I tested? Have I prioritized? Have I gone through all the process? Are this working as expected? What are the bugs? Have I done my traceability matrix? All these are the things that you would decide that, yes, now I'm confident to say I've finished testing. What are the general principles of general testing principles? 7 of them. Testing shows the presence of bug. You all agree with me. Exhaustive testing is impossible. Definitely. Early testing, that is agile. You ensure that, yes, you are testing at every phase and all the time. Traceability matches, you'll be taught. So traceability matrix are like for instance, if you are given a requirement, maybe let me give you a requirement of login, that user should be able to log in. So that is a requirement. That is a user story. That is a requirement. It could be a BRD. So this requirement, when you write your test cases, for user to be able to log in, what are the login test cases that you have written? User is able to log in correctly with all details, correct username, correct password. That is one scenario. User is able to log in, is not able to log in with maybe username correct, incorrect password. So it should fail. Maybe you've written like 10 scenarios for login. So now you want to map it, you want to trace it. So you've got the user story, which says login is the requirement. Now, all your test cases that you've written, that you've put into there, you just link it to that login. So anybody that goes to login and see the requirement login, they can see all the test cases that you have tested for login. They don't need to come and meet the tester. They'll know that yes, the tester has actually done his own job. Test case A, maybe the TFS ID or maybe Jadura Devils ID, any ID linked to it is there. They go to the ID. Oh, yes, it's covered this. So those are the things called traceability matrix. I'm tracing back to what the requirement is using my test cases. So which means that is my own test coverage. So defect cluttering, pesticide paradox, testing is context dependent, absence of error fallacy. 7 general testing principles. Then fundamental test process. Five. Five fundamental test process. 7 general testing principles. 5 fundamental test process. 1. Testing, test planning and control. 2. Test analysis and design. 3. Test implementation and execution. 4. Evaluating exit criteria and reporting. 5. Test closure and activities. I'm also taking questions as a, does the textbook include revision? Yes, there's a self-assessment, like a quick recap in the textbook. You see it is a session there that you could actually see. Yes, there are self-assessment you can test and the recap there. Yes, at every topic. Yes, I think so. Yes, and you can also you can if you like if you don't want the soft copy, you can buy it. You can buy the textbook. It's online. We use fundamental test process. You see the flow, but you might the one that you're seeing currently might be too the soft copy might be kind of expensive if you want to buy it that same edition. But if you take the latest edition by the same author, then you are going to get you can get it as cheap as less than 30 quid. So that is fundamental. So those are the fundamental test process. So which I've mentioned. Always have it is at a level and it must follow. Just have it there that test planning and control, test design and analysis, test implementation and execution, evaluating exit criteria and reporting, then test closure activity. Then that's the psychology of testing, and those are the different levels of testing. For today, he's just mainly introducing you to testing, and just for you to understand and know that testing is not rocket science. It's easy. It's something you do daily, and it's something that you will continue to do. So everyone, if you are testing in any phase clinically, even before the pandemic, we've got COVID-19, there were trial sessions. Those were testing sessions. You can see. So testing is a key thing in any aspect or any area of life. So testing can never ever go out. You will continue to test. When you wake up in the morning, you will test in during the pandemic, before the vaccine, there were trial sessions. Even any research, there are always trial session. So all these, they are testing phases, which does. How long does it take to get a job in software testing as a fresher? Honestly, after the internship, I'm not even to say it, but it depends on how you persevere, how you actually work hard in terms of learning skills, how you read, how you can. I don't see anything long in getting any job. To be honest, you can get it as quickly as you need to do. You need to put in work. Yeah, that's it. You just need to put if you want to get anything, it's just like you saying you want to do something, you have to just once you put in the hard work, you should be able to get it at any time. So some get it within a month of joining. Yeah, absolutely. So within it has the internship is so intense that it's hands-on. So definitely you're working, you're getting it, and you're actually using it practically because you've got access to unlimited tools. You can use different tools that are being used. It's just going to be like a work environment, just a committed time, few hours in a day. Man, you can get it anytime. So I'll say um, if you have any question before we finish the class, we've got a minute left. So any question before we finish the class? So in the next class, we'll start with software. That's the next lecture. So any question before we finish the class? So once again, I just welcome you all into it. It's an interesting class. It's an interesting job. You always be you cont- once you're into it, you won't want to leave it. I've been testing. I don't even want to move to another. So it's something you keep enjoying and doing. You have different knowledge from the business analysts, from people, and from the whole wild team. Once again, I welcome you all, and hopefully we'll see you in the next class, which is on Monday. How can those in Nigeria join the internship? Just go to Telegram as you're there. You can just add your name, just send your name to the Telegram. Will contact you and we can tell you how you can join. It's online course and is hands-on. Yes. So thank you everyone. In the absence of, let me say, cloud and software testing combinable. Yes. Oof. If I'm getting what this person saying, then it means yeah. So thank you to everyone, and we'll meet again on the night. Thank you all. See you. Good night.